All right, let's go over the first one, make sure we're on board.
So 25.
So here, can I split my data perfectly in half? No, you can't. So do the best you can. Leave out that one guy because you can't split perfectly in half. Then I need to find the median of this lower half. I have an even number, so I don't have one guy tied. I have two people tied to the middle. Does everyone follow what I'm saying? So I have to average them. Average these two, I get 25. That's my Q1. Over here, same thing. Average these two guys, that's my Q3. And then there's only one in the middle, so that's my Q2. And then I have my min and my max. So here it's going to be 14, comma 25, comma 38, comma 58, comma 73.
Oh yeah, the median.
You guys need another 20 seconds to do the bottom part,
Because
part B.
so 14 is your minimum.
Yes, who needs more than a minute to do part B?
Number 2, you have to find. So the but, yeah. So then you will do 14.
All right, so for part B,
So you just
again, split it perfectly in half. Can I split it perfectly in half?
Yes.
Yes. So it's a little bit easier. Split it perfectly in half. Now find the median of the lower half. Are there two of them tied for the middle here? No. No, just one guy all by himself. That's my Q1. Same thing. The upper half better be the same as the lower half. That's my Q3. And then how about my median? Is there one guy in the middle for the median? No, so you have to average the two in the middle. That's my Q2, or my median, my overall median. And then you have your min and your max. So this one would be 14, comma 27, comma 40, comma 55, comma 73. Okay. Now we have box plots. Box plots, they're only going to worth a few points on your exam, but I have a few points out of 100. It's still a few points. They're also pretty easy, but again, you have to follow a couple of the rules and not do some grievous errors that I will mark you off for. So Angel, why don't you go ahead and read?
A box plot or box and whisker diagram is a graph of data of a data set that consists of a line extending from the minimum value to the maximum value and the box with lines drawn the first quartile Q1, the median, and the third quartile Q3.
Great. So we're on the back page now, right? You guys have filled in that first blank, yes?
Yes.
Okay, good. Here's some pictures of them. Right, so lines through the Q1, Q3, and the median, and then lines out to the min and the max. So everybody take a look at this one. Is it symmetrical?
No.
No, it's not. So it's kind of, so you can see sort of how like the data is sort of like pulled off and more towards the left than it is towards the right. Everybody kind of see that? Most of the data is kind of in here. You should be able to tell that right away from looking at it. You should not do this, and people will. 1.5, 35, 68, 113, and 225. So what they're telling me is that those are all equal. They're just putting up, you can't tell anything from that picture up there. The graph, you should tell them looking at the graph where your data is. Like if you look at a histogram, you should be able to tell like some things are really high and some things are really low, right? From that graph, you can't tell what's high or low because all it does is just throw them up there just like a picture. And it doesn't show you where things are really at. So don't do this because you will lose 3 points, 3 very easy points on the exam. See how this one's kind of more normal shaped? Everyone see that one? It's symmetric roughly and kind of centered around the middle and roughly symmetrical left to right side. And then this one, is this one normally distributed? No, it's totally, so especially this one. If you give me this like that, you will lose the 3 easiest points, 3 of the easiest points, not the 3 easiest. There's a bunch of easy points on this exam. There's also some hard ones, but there's a bunch of easy ones as well. If you do that, big trouble, right? I need to be able to tell, you should be able to tell from looking at a graph what your data is like. Not from having to read the numbers, but from looking at the graph itself. It should give you information. Okay. The best way to do that is to give yourself a number line that's equal increments, right? 10, 20, 30, 40, 50, or 0, 20, 40, 60, 80 along the bottom. That's, you know, and then plot your points and draw them in. So here I have my little number line. I'm going to do it for this number here. So 10 is about right here, 24.5 about there, 39.5 about there, 65 about there, and 90 out here. And then I'm going to draw a box through the quartiles and through the median and then out to the sides like that. Is that all right for everybody? Okay, so I think you guys are supposed to do it for problem 6B, which is that last one. So I want you guys to draw your box plot. Is this your box? This isn't yours, is it? No. You guys do this one. And again, I would do a number line first. Draw on a number line. What's your smallest number? 14? So maybe you start at 10. And what's your highest number? 73. So maybe you go to 80, 10, 20, 30, 40, 50, 60, 70, 80. Don't do it like this. Don't do like 10, 20, 30, 40, 50, 60. That's going to get you in trouble too. Does everyone see what I'm talking about? Like if you give me a really messed up number line where it's not at all equal, right? If it's more or less equal, then you're fine. But don't give me some garbage like that. Because I'll take off points on the exam for that too. Does someone want to read out for me what they were? What was your prime number summary last time? Problem 5B?
14, 27, 40, 55, 73.
Great. All right, everybody do it. Do it, do it, do it. You don't have to write those down. Just make your box plot, and then they'll come in. Put them in where they go. Put a dot above for every point, and then draw your lines. Super straightforward. I wrote them up there. They're up there. They're right up there. So just give me a number line that, before you even look at your numbers, just give me a straight up number line. Nice and even. Go by 10s or go by 20s, depending on what your data is. 14, 27, 40, 55, 73. Did you guys do this? Everybody have this so far? Everybody look up. Everybody look up. Everybody look up. Did you guys do this so far? Right, you have your number line, you have your dots above it? Great. Then just put box around your quartiles and out to your ends, and you're done. Okay. Any questions on this one? Anybody need a minute to confer with their neighbors, or half a minute?
Yes.
Okay, take 30 seconds to confer with your neighbors. Armida, you put a box around the middle one. If it box around the middle ones, and then it lines up the outside. Okay. All right. Let's go with Michael. Michael, go ahead and read for us.
An outlier is a value that lies very far away from the vast majority of the other values in the data set. An outlier can have a dramatic effect on the mean and standard deviation. A data value less than Q1 minus 1.5
IQR, yeah.
or greater than Q3 plus 1.5 IQR can be considered an outlier.
Right, so this is our definition of an outlier. We're on the back page, right? And you guys have filled in that first spot at least. Here's an example. So here is my data. I need to figure out what the Q1 and Q3 are. I can split it perfectly in half. So my Q1 is, what's my Q1? 4, that's my Q1. And 10 is my Q3. Everybody good with that part? So my IQR is going to be Q3 minus Q1. That's 10 minus 4, or 6. Now I need 1.5 of those. If I have $6 and someone else has 1.5 times what I have, how much do they have? $9. Yes, $6 plus half again, plus 3, $9. So 1.5 IQRs is equal to 6 times 1.5, or 9. That is how much I need to subtract from Q1 and add to Q3 to figure out kind of my boundaries of where my, kind of the outlier boundary. Beyond this, you're an outlier. Right? We've got to figure out where those boundaries are. So for the lower edge, I don't know if you call it the edge, I don't know what you guys want to call it, would be Q1 minus 1.5 IQR. Oops, IQR. So that would be 4 minus 9, negative 5. The upper edge is Q3 plus 1.5 IQRs. So what's my Q3? 10? 10 plus 9, 19. So that means everything from, you kind of look at it, everything from -5 to 19 is not an outlier. It might be unusual, but it's not an outlier. It's not crazy far away. So this is all the kind of the non-outlier land. Do I have anything that lies in outlier land beyond this? Does 2 is 2 beyond my outlier range? No, it's going to fall inside of here. How about 20? Yeah, it's going to fall outside. So 20 would be an outlier. This one would be an outlier. Okay? You will have to do this for part of your project, part 5. It will come up in there. So, it's a good thing we're kind of going over it now. So I want you guys to do lab problem 7. I already gave you the 5-number summary, so you do not have to find Q1 and Q3. They've been found for you. Just use them. Find your IQR. Everybody find your IQR. Take 30 seconds, find your IQR. Everybody find it. You get it? IQR? Hey, Prab, what's your IQR?
Oh, no, I didn't get it. Hold on.
Okay, do it. So remember, your IQR is Q3 minus Q1. What's my Q3?
61.
61. What's my Q1? 23. Subtract them.
38.
38? Great. So that's the first step. Now we need to figure out now we need to do Q1 minus 1.5 IQRs. So that's going to be, what's Q1? Everyone find that. Figure out what Q1 is, and then subtract 1.5 times, or is it better to find 1.5 IQRs first? Is that easier for people? Is that, okay, so first find 1.5 IQRs. Let's do that. That's probably easier. Okay, Corey, what'd you get? 57. Good. Now, you need to take that number and just subtract that from Q1 to get your lower boundary, and take that same number and add it to Q3 to get your upper boundary. Everybody do that.
I have now 57, and then at the first one, 40 minus 57, and 120 minus
Start from
57.
the lower boundary, and then you take Q3 and
What
add
she
that
said
to
is
the upper boundary at the upper edge.
Mm,
What's your Q1?
So,
Where's your Q1?
you're subtracting 120 from.
You're not even looking at that yet. Look at this part here. Less than this or greater than that?
Oh, yeah.
So read above it where it says on your instructions, it says a data value less than Q1 minus 1.5 IQRs or greater than Q3 plus 1.5 IQRs is an outlier. You need to find those two numbers.
Yeah.
It's right here. Right there.
I'm sorry, I did wrong. It's 60 plus 57. Sorry, it's not minus. It's good.
Oh yeah, because it's on the positive side.
Yeah. How is it?
120 plus 57.
No, we're gonna take the Q3. That's the max, the Q3. Q3 plus the... So Q3 plus 1.5, which we have
Okay,
67.
so our lower limit is going to be our lower edge
61. The Q3.
is going to be
Because we already have
Q1 minus 57.
Yeah.
What's Q1?
61 plus 57.
23. Negative 34. Is that right?
Right.
Oh, I did here wrong.
No, wait. Negative 30.
Yeah, that's right.
Okay. And then our upper edge
Yeah, no.
is Q3 plus 57. So that's going to be, what's our Q3?
61.
61 plus 57? 118. So those are our boundaries. So from negative 34 to 118. Anything beyond there is an outlier. Is 120 an outlier? Yes. It's beyond that. Is 14 an outlier? No, because it's right inside. It's inside this range. All right, so you guys go ahead and grab your chapter 5 notes. Put these ones away if you haven't put them away or whatever you do. And pull out chapter 5 notes. All right, let's get a reader. Jaime, go ahead and read the first part for us.
A random variable, RV, is a variable whose values are determined by chance.
Keep going.
A discrete RV assumes a finite number
Finite.
of finite numbers of values between 2 points and can be counted.
Right, so discrete can be counted. Keep going.
A continuous RV has infinite possible values between 2 points and comes from data that is measured.
Right, continuous are things you measure. Discrete random variable. Should be filling stuff out here, right? Next. Vanessa, go ahead. Vanessa C.
A discrete probability distribution consists of the values of a random variable assumed and the corresponding probabilities of the values. The sum of the probabilities of all events in a sample space added to 1. each probability is between 0 and 1 inclusively.
Perfect. So you guys should have this filled out. So here are the things. Probability distribution. So you take everything in your sample space. So see where it says X here, guys? I don't look up. See where it says X? You're going to list everything in your sample space. And then, see where it says probability of X? You can list the probability for each one of those. If I flip a coin, a dice, or if I roll a dice, what are my possible outcomes? 6 is one. What else? 1 is another one. 2, 3, 4, and 5. 1, 2, 3, 4, 5. 6. This is my sample space. So these are my possible outcomes. Every possible outcome. And the probability for each one of those. This is a probability distribution. Where you list every possible outcome of X and the probability for each one of those. You can also represent it graphically, right? There's a little graph of it. If I flip a coin 6 times, how many heads could I get? 6 or 0. I could get 0 or any number between them, right? So my possible outcomes are 0 through 6. What's the most likely? If I flip a coin 6 times, what's most likely? What do I expect? 3. I expect 3. So 3 is the most likely outcome, right? But I could get a 2 or a 4. I might get a 1 or a 5. Very rarely would I ever get 0 or 6. It's possible, but not super likely. Highly unlikely. So this is a probability distribution graph, and above that is the probability distribution. The rules again for probability distribution. Right, it has to the sum of the probabilities had better add up to 1. Also, can a probability ever be negative?
No.
Can it ever be greater than 1? No. So you guys, first of all, the first question is, what do you guys think about these two? Take 30 seconds with your neighbors and discuss the top one, and if you can, the bottom one, of whether or not those could possibly be probability distributions. Okay, so the top one, can the top one be a probability distribution?
Yes.
Yes. Why? If you add these up, they equal 1 or 100%. How about the bottom one?
No.
No. Why?
It equals 0.7.
Yeah, if you add them up, it does not equal 1. What else?
It's not 0.
Yeah, you have a negative probability. That's not possible. Make sense? Everybody okay with this part? All right. I would like you guys to create a probability distribution for this one. So you have X, and you have probability of X. What are the possible outcomes? What can the child do? What was that? See where it says the probability? What probability? Probability of what?
Whatever they're playing.
Yeah, which is what? What's the first one?
Computer.
Computer. C. That's one possible outcome. What's the probability of computer? 0.45. Great. Next one. dress up. So figure out the probability of that, and then figure out the other two. What are the options? What are the other options? Blocks and paint. What's probably of dress up?
0.27.
Yep. And blocks.
0.18,
And last one.
0.1.
Put one. Great. We're gonna skip the drawing a picture part. That's okay. I want to talk a little bit about this mean or expected value. The expected value is the mean. They are the same thing. Mean and expected value. So mean or expected value, I should be writing that in, it's a weighted distribution. So you multiply every x value by its weight, by its probability. The beautiful part about it is if you add up all of the probabilities, they better equal what? 1. So you don't have to worry about dividing by 1 because it's the same thing. So you can skip the having to divide by part. So here's an example. First of all, say you had the numbers, I have the numbers 1, 2, and 3 in a box. And I draw. And I put it back. I draw over and over again. On average, what am I going to draw? All right, let's put it this way. You go to your grandma's house. And when you leave, she spins a little wheel that could be 1 or 2 or 3 and it's random, equally likely. And then she gives you that many dollars. She gives you $1 or $2 or $3 depending upon what the wheel says. On average, how much money are you going to make going to grandma? Well, it has a $1, a $2, or a $3 on it. On average, how much money do we make going to grandma's? $2. Because for every time you roll a 1, she spins a 1, she'll spin a 3. Those will average out to 2. And then she can also do a 2. Does that make more sense? Okay. So here we have 1/3 chance, plus 2, which has a 1/3 chance, plus 3, which has a 1/3 chance. So multiply every probability by its, every x value by its probability, and add them up. Right? 1 times 1/3 is 1/3, 2 times 1/3 is 2/3, 3 times 1/3 is 1. Add those up, you get 2. That's the mean. That's the expected value. That's what you expect to get. I'll do another example. I roll a dice. What could happen when I roll a dice? We just talked about it a second ago. You know, 1, 2, 3, 4, 5, or 6. All 1/6 chance each of happening. So the first one, 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. So you multiply each one of those, so I get 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. And you add all those up, you will get 21/6 or 3.5. That's my expected value. You guys said, these are my x's. You guys said the possibilities were $3, $2, figure out the rest of them. And then for every x, you need to figure out the probability of that x. What's the probability I grab a $3 bag? How many $3 bags are there? 15. So is my probability 15? 1,500%? 15 out of 25. 15 out of 25. Figure out all the rest of these. Do you guys get these ones yet? $3, $2, what else could I get? Figure out all the probabilities of each of them.
You already did it? Wait, did you multiply by this? Did you multiply the top by the bottom? Wait. So she multiplied these two and then she added, like you multiply them and then you add them up.
So what are the other possibilities?
5, 10, 20.
Right. Jake.
So first you put the
5, 10, 20. Assuming you want the stuff in there. So what's probably drawing a $2 bag? 6 out of 25, $5 bag?
I don't know, you have to do it.
25, $10 bag? And last one? Great, now you need to find the expected value. So you're going to multiply every x value by its probability. 3 times 15 over 25 plus 2 times 6 over 25 plus 5 over 2 times 2 over 25 plus 10 times 1 over 25 plus 20 times 1 over 25. And what do you guys get?
So then,
388.
well, it's a double set.
Have a good weekend.
Oh, okay.